So it's been a little bit over a month with my EcoFlow STREAM series of batteries connected to my 3.6 kilowatts of solar panels in my backyard. Not the most ideal situation, but I wanted to go a little bit more in depth on how much it's actually saving me, real world numbers, and also do some testing in terms of how much you're actually able to get out of the battery systems and what the round trip efficiency is of the EcoFlow STREAM series of batteries that I have on hand over here. Now keep in mind that EcoFlow is also the sponsor of this video, but they have no input over what I say in the video. And all of the real world testing and all of the efficiency numbers that we come up with, you can just take those numbers and compare it to different brands. So in the video from last month, we went a little bit more in depth into the tech side of it and how it's actually set up and what the EcoFlow ecosystem allows you to do and that kind of stuff. So if you don't understand the system yet, you can definitely check out that video. But for this one, we're just going to go into the real world performance numbers, and then afterwards I'll show you all my test results in terms of the battery systems themselves, and we can go through it here. So the number at the top is the total consumption for that day. So 8.16 kilowatt hours, and 3.69 came from the solar panels, 3.13 came from the battery system, and then we sucked only 1.34 kilowatt hours from the grid. And you'll see this quite a lot in the consumption stats here because I always have like 1 kilowatt of power draw from the grid. That's mostly due to the peak performance, I believe, and maybe also because I don't have enough batteries or maybe I don't have enough solar panels. You can see that during the night, it pulls from the grid a lot, and that means the battery is essentially empty. So I'm just going to skip through these performance numbers here so you can pause the video if you're interested in it. But these are my specific numbers, my specific situation, of course, and it's entirely dependent on what you have going on to how efficient it's going to be and how much it's going to be saving you. Now, of course, all of the manufacturers from home battery systems will put the actual specification of how much kilowatt hours is capable of being stored on the battery system itself in terms of how many cells are installed on the device, right? But it doesn't really tell you how efficient the system is. So how much are we actually able to pull out of the batteries and how much is being lost during the transfer? We kind of need to measure that to ascertain if these cells are good or if the battery unit is well put together. So to measure this, we can charge the battery to 100% and then discharge it and measure the output via a Shelly power plug and see how much it actually outputs. We're discharging this one to 10%, that's the limit, so it doesn't actually damage the cells. So I only measured the STREAM AC Pro and it has a rated capacity of 1.92 kilowatt hours. Now I discharged it to 10% as I mentioned earlier, and what I was able to get out of the battery is 1.55 kilowatt hours of usable electricity. Now because the battery still has 10% remaining, we can estimate the usable capacity, and that works out to roughly 1.72 kilowatt hours of usable electricity compared to EcoFlow's advertised 1.92 kilowatt hour battery capacity. Now you have to keep in mind that that is an estimate based on the reported state of charge, so we're kind of assuming that that reported state of charge is accurate. The figure that actually matters most here is of course that 1.55 kilowatt hours that I was able to measure out of the device. The next step is to measure how much electricity it takes to charge the battery back up from 10% to 100%. And this will later allow us to determine the round trip efficiency of the entire system. So charged it back up from 10% to 100%, it consumed about 2.05 kilowatt hours from the grid. And earlier during the discharge test, I was able to get 1.55 kilowatt hours of usable AC electricity out of the battery unit. That means we take the output and divide it by the input, and then we get an efficiency rating of 75.6%. So that essentially means that for every 1 kilowatt hour I put into the battery, I get 0.76 kilowatt hours of usable electricity back out of the battery. And the rest is lost through the charging electronics and all of the other stuff that's going on. Now, when I was charging the battery, it consumed a fairly consistent 1040 watts, and I didn't notice any thermal throttling in any regard. It did get hot to the touch, but not to the point where I can burn my fingers or anything like that. I don't actually have a thermal camera to see if the heat is being dissipated nicely through the heatsink at the back over there. So you have to check out a different video to actually ascertain that. In terms of that cooling system though, it's completely passive, right? You don't hear any fan noise. There's no electrical noise coming from the device either. It's entirely silent. Now the next thing I wanted to see is how it performed under higher loads. So my washing machine sucks about 1800 watts. I connected that to the back of the unit and then I connected it to the grid. Now even though the power sockets at the back of the units are only rated for 1200 watts, if you connect it to the grid, it will go into some sort of pass-through mode and it supplies enough power to actually keep the washing machine running. But as soon as I disconnect it from the grid, it pretty much immediately went into the overcharge protection mode and it shut down the device entirely. I did get an error miss in the application as well, indicating what had happened, but this is a pretty decent result. That means that there's safety protections in place and it will actually activate the protective features to save the battery unit. EcoFlow also advertises a UPS backup mode, which is one of the more interesting features for me personally. I really like integrating these things into the little carts and stuff. And I tested this by integrating it into a 3D print cart, connected to my 3D printer to it, connected it to the wall outlet, had a 3D print going, and then disconnected it from the grid. And the 3D print just kept going. There was no interruption on the 3D printer, so that's really good. I don't have any additional equipment to measure how many milliseconds the UPS backup actually is, but in all of my testing, it performed really nice. Something I want to briefly mention in this video, which I also covered in the other video, is how good the software integration is. So everything popped up in the application straight as it was turned on, and it was really easy to set everything up. And in general, sometimes it's a little bit confusing coming from other systems, but it seems to be working really quite nicely and it's very stable. Even though the efficiency ratings are a little bit lower than I actually expected, I do appreciate the EcoFlow system the most out of most of the units that I've received so far, because it's just so reliable. It works all of the time. I haven't had any issues with it yet, and the application is really stable as well. So I do recommend it, but I hope they look into those efficiency ratings and see if they can up the efficiency of their newer products and actually get that up to par with the rest of the battery market. So I was checking out the EcoFlow website, and they seem to have released their newest generation of these home battery systems. This is the STREAM AC 5000. It seems to be a very dense little battery pack, so it's compact in size, but it seems to have increased output capacity as well. So definitely check that out. I left the link down below. But yeah, I hope you enjoyed the video. I hope it was helpful. If it was, leave a like, leave a comment, and hopefully see you in the next video.